Good afternoon, everyone. So right now we're going to have a very interesting panel. I'm sure you have all been tracking Bitcoin, and just to coincide with the panel, the the conference, the price is also rising, right? Uh, but we are not going to talk about cryptocurrencies in this panel. This panel is going to look at applications of blockchain beyond cryptocurrencies, essentially. What are the opportunities? What are the challenges? Okay, so that's me. I'm going to be the moderator. I'm Salil. I'm a professor at UNSW Sydney. I won't take up a lot of time. You can read up the bio later. But what I'm really interested in is introducing the four panelists who we have today. And as you see, if we put a table here, it's going to block the screen. So what we might actually do is I'll go through a very brief introduction of the panelists and the questions I've asked them. And then perhaps each of them can come up here, talk a bit about these questions. And then we'll put the chairs in, get everyone seated, and open the floor up to all of you to ask questions, raise concerns, and so on. Okay. So in no particular order, actually in a chronological order, starting with their last names. Let me first start off by introducing our Dr. Moody Alam, who's sitting at the back. Moody is with the IOTA Foundation, and he recently joined there as the Director of Research. And I believe you're based in the UK, right, Moody? Yeah. And he's got a PhD in distributed AI. He's a fellow of the Royal Statistical Society, and so on and so forth. And again, I won't go through the entire bio. All this is on the webpage. So welcome, Moody. Looking forward to your views. Next, we have Professor Bhaskar Krishnamachari. Bhaskar. Oh, yeah, right here. Sorry. So Bhaskar is with the University of Southern California in LA. He's a director of the Viterbi Center, where he works on IoT, cyber-physical systems, and of course, blockchain. So looking forward to Bhaskar's input as well. Next, we have Dr. Kang-Won Lee up here. He's probably had to travel the least, given he works in this very building. He's from SK Telecom. He heads the software R&D at SK Telecom, and he spent some time in the US at UIUC and also here at Seoul National University. Yeah, and he's a ACM distinguished scientist. And last but not least, of course, Professor Burkhard Stiller at the back there, who's looking after the communication systems group at the University of Zurich. And he's also one of the TPC co-chairs of this event. You might have seen him up here earlier today. Okay, so the questions I kind of posed to them are as follows. Maybe I'll just move this out of the way so you can see. Essentially, there's been a lot of talk of blockchain, particularly in the context of cryptocurrencies, right? So what we're asking our panelists is, okay, where do they see blockchains best fit? In what kind of applications may benefit the most? What are the key challenges in adopting blockchains in those applications? Next, where do we see a wider adoption of this technology? And what is perhaps holding this back? And lastly, sort of taking a 10-year view and predicting, I guess, where blockchain research might be in the next 10 years or so. Okay, and that's all I have to say. I guess I'll hand over to the panel. I would encourage both the panelists and all of you to raise some controversial topics. Okay, it's not nice if everyone agrees on everything here, right? So please try to be controversial. So I'll hand off to Moody to get us started. And it's very interesting. So we have four panelists, right? And the two professors prepared slides, and the two people from industry didn't prepare slides. Or did you prepare slides as well? Okay, no. Okay.
Oh, okay. Hi. So, Moody alarm, and the first thing that I normally tell people is that Moody is a condensed form of Mudasar. Doesn't describe my personality at all. So the questions are pretty much straightforward. So I'm actually at IOTA Foundation. I joined them not so long ago. My background is specifically in AI. I have a PhD in distributed artificial intelligence, and worked in academia and government and industry. So, so the questions that are relatively, I found them relatively straightforward. And this is why, I didn't think that we'll have to prepare slides, or maybe I was just lazy. But it's the four questions. The first question of what application can best benefit from blockchains? So, so you were talking about controversy. So I'll bring one at the beginning, which is the very word blockchain. So I think it's pretty much now synonymous with DLT. We use it as a rather than saying DLT. So when I talk about blockchain, it's actually DLT in general, not just blockchain. And the applications, I think it would be easier to say, which applications won't use blockchain in future. But of course, the range is from governments to healthcare, to finance, and all the way down to any industry that you can think of that is storing data, where people are involved. There's a need for security and decentralization. That's where blockchain is going to make a difference. So I do see it in lots of domains. That it's going to be the application dApps especially will be developed for that. Another area that I want to talk about, and I probably will talk later about that as well, is the application of AI in blockchain and applying blockchain to AI systems. And this is something that I think haven't received as much attention so far. But this is another very novel application that I foresee. What are the key research challenges? Now, so research challenges, of course, when we talk about DLT in general, I think the research challenges come from that classic trilemma of scalability, security, and decentralization. And if you look at all these specific research challenges, you will find that actually they fall within these three categories. And I think we're not there when it comes to solving or extending the boundaries of this trilemma. So we are still struggling with these things. Of course, there is some progress, but these are still the key research questions that nobody has answered comprehensively. When can we expect to see wider adoptions? So I think, and I really hope nobody is going to hold me accountable for this, but I think it will probably be a couple of years when we see more and more applications. But if I have to give you a number, I would probably say within 5 years, I see that it will be, I feel that it will be widely applied in enterprise setting. What is holding this back? I think a couple of things with the enterprise, especially in enterprise setting. Enterprises solutions have to be enterprise ready, as they say, which means they are scalable, they are focused on business, they are production ready. And I think this is where really blockchain and all the DLT technologies are put to test to their limits. And this is why this is what is holding it up. I also think that DLT is actually it's a great transformative technology. However, it's still relatively young technology, and we have come a long way since it was introduced. But I think it still needs its challenges or fixes before it can become an everyday reality. And also the challenges that I talked about trilemma, I think those challenges are another reason for that is holding this back. So how do we envision blockchain technology maturing 10 years down the line? I think 10 years is a long time, but I do think that given that the interest that blockchain and DLT technologies have generated, and given that lots of research is going on in this direction, I think it is safe to say that we will have a highly scalable solutions which are available, perhaps permissionless to everybody, and things like smart contracts will become pretty much a default in blockchain. And I also think that the technology will mature in terms of how these nodes, there will be more intelligence in the nodes. If you look at the systems right now, there is a adaptive behavior, and but it's not really making use of a lot of intelligence, as I referred to earlier. So these are the things that I envision in 10 years down the line. That's all from my side.
Okay, next I would like to invite Bhaskar.
Great. Thanks, Salil. So I'm going to use some slides because I thought I'd use the opportunity to also talk about some of the work we're doing that will answer some of these questions that are raised for the panel. So the first thing I like to say when talking about blockchain technology, or more broadly about distributed ledger technologies, is at least as engineers, at least those of us that are not in the business of pushing one particular protocol, in the sort of competitive market of blockchain protocols out there, that we should be really looking at blockchain as a collection of capabilities, as a collection of technologies, and a collection of components, and thinking about the problems for which these components are a good fit, and then designing the systems to solve those problems. So not starting with a hammer and looking around for nails, but look at the diverse range of problems that we encounter and see what is the tool we need to shape, what is the system we need to build that will answer and address that question. So I think this kind of more engineering view of blockchain is still not the dominant way people are thinking about blockchain technologies. They're focused still very much on, let's build a protocol, let's speculate with the underlying coins. So if I think about it in these terms, what are some applications where these set of tools, these technologies, these capabilities that are coming online, what are some sets of problems they will allow us to address that we haven't done a good job of to date, right? And I'm going to pick two in particular that interest me, and I think there are many more than this. The first is to really create a trusted data value chain for the Internet of Things. And I'll expand on what I mean by that, but at a very high level, it's really thinking afresh about networks as not just being dumb pipes that carry bits, but really being networks that support the ability to move data that has value for the end user and allow the value exchange to happen as you're moving the data. And at the same time, allow the sharing of this data in such a way that you can trust that what you're seeing is really what you should see, that it's not being manipulated, that you have a level of confidence in this. And this aspect of trusted data sharing also shows up not just in data chains, but also chains involving physical goods, which we refer to as supply chains, right? So I think these sort of data value chains and supply chains are two broad areas where some of the tools that are emerging with blockchain technologies are going to be helpful. So in terms of challenges, I kind of have a couple of bullet points here. Of course, I echo the comments about everything from increasing the transactions per second to lowering the confirmation latencies to improving energy efficiency and so on. There's a number of these engineering challenges that many of us are engaged in addressing. And until then, it's like flying an airplane where we're building it. But over and above that, I have kind of a couple of bullets here. One talking about kind of a business challenge, if you will, that arises in adopting this technology, and the other still a collection of technical challenges that need a lot of attention. So the business challenge in terms of what is really inhibiting adoption of blockchain technologies is that there's a very high activation energy when you talk about enterprise use cases to bringing together these consortia of different businesses with their own self-interest and build tools that have to be adopted not by one company at a time, but really by collections of them together, right? So I think there's sort of this phase of several years, I think, that we'll be in before we'll see successful examples of production supply chains using blockchain technology or even some of these data value chains that I'm speaking about. But from a technical perspective, there's some very fundamental things that we haven't really built, that we don't have good engineering artifacts that support. Decentralized search, recommendation, curation, and reputation systems. So if you take, for example, web browsing or web searching, we've got the Googles of the world that have kind of centralized the task of building a search engine. But at the end of the day, they get to manipulate and control how they rank the search results, how they choose to present to you, what you get when you search for something. What does a truly decentralized search system look like is something that we don't quite have. And there's sort of similar problems associated with curating content in a decentralized way that cannot be manipulated. So ultimately, I think what we'll have at the end of maybe 10 years of work is towards pushing us from today's internet to one that is really based on having a value-based trust layer for all these different interactions that multiple organizations might want to have over the internet. So when we talk about having these economic interactions, the first place that you can start to explore is what do internet protocols look like if they already bake in the notion of paying for data? So instead of HTTP, a client telling the server, I want some data, and the server saying, here you go, what does it mean for the client to say, I'm looking to buy data, the server saying, here's some menu of data, these are the prices associated with it, the client saying, I'd like to order this one, the server saying, this is how much it would cost, the buyer saying, I agree to pay that, the server providing the data, providing invoices, making payments for that data as you go. So the whole value transaction of data baked into an application layer protocol. So this is our attempt at doing that. It's a protocol called SDPP, where essentially in addition to the traditional TCP socket connecting the client and server, we also have channels for payment and recording invoices and other kind of components of the transaction. As you think about marketplaces for data, you realize that you can uncover a lot of value in, for example, smart cities by allowing application developers to come to a marketplace and say, what types of data are available for me from the city that I can build my application, that I might need to pay the owners of that set of data for, right? And on the other end of it, what are the incentives you need as a data owner? Under what conditions will you be willing to share your data, with whom, when, at what price, and so on? And so as you build these types of marketplaces, we have an effort in Los Angeles, starting out of Los Angeles, called I3. An interesting question to ask is, can you make such a marketplace truly decentralized? So that whoever is running the marketplace platform doesn't have the ability to manipulate and tamper with what recommendations of data sources they present to you, and essentially remove that sort of monopoly power that marketplace owners have today on web-based marketplace platforms, whether it's eBay or Amazon, or even Yelp. When you look at sort of recommendations, you can never be sure that what you're seeing is something that's in your interest versus the interest of the party that's hosting that set of recommendations. So we've laid out in some work last year kind of an architecture for different components that would need to be built to realize such a decentralized data marketplace. Many of these components don't exist today. As I said before, having a truly decentralized search mechanism, truly decentralized recommendation systems, curation systems, these are all things that researchers can easily spend, I think, several years putting together. For example, if you look at decentralized curation, there is a literature growing and systems that have been put out there on token curated registries. But when we set to look at what these schemes look like out there and you examine them critically, for example, doing some game theoretic analysis, you find that there are problematic assumptions baked into the way these systems have been put out. That, for example, that there's work that's needed to increase engagement in these types of token-based curation systems and so on. So I think these are examples of things where research can help us. And then finally, with respect to applications with movements of physical goods, there's still sort of this data sharing component and trust associated with the data sharing component that we're seeing a lot of need for. This morning, for example, Dr. Ramachandran from our group presented a decentralized pub-sub mechanism, having the ability to share data in ways that cannot be manipulated by Byzantine adversaries, sort of an example of where work needs to be done that doesn't sort of exist today. So to kind of summarize, I think the outlook is bright, the applications exist, the challenges are real. I think there is a decade of research ahead of us to address these challenges. So personally, I'm quite optimistic that we're really moving technology and the applications forward as we begin to understand what the capabilities are. Stop there.
Okay, so my name is Kang-Won. I met all of you this morning. So yeah, indeed, when I talked to Professor Kanhere this morning, I didn't have slides. Then I thought probably it's better to have some slides to go with the story. So his question was, I think this summarizes the question. What are the enterprise applications of blockchain, today? And what are the challenges? Now, so I took, this view of an alien. So I'm an alien. I came to the Earth. I heard about the keyword called blockchain, and then I started doing some Google search, like any intelligent being would do. And I find a lot of things, actually, these are not some small projects. These are not just no-name projects. These are global companies like IBM. They have lots of blockchain use cases for payment system, food supply, you name it. Same thing from SAP. Also, they have lots of activities for smart. Sorry, some of the words are Korean, but basically they have applications from device protection to oil and gas services. Microsoft also has lots of blockchain-based services on financial services and the supply chain and digital ID and data exchange. AWS, one of the biggest platform provider, now has managed blockchain services. So they are now selling it. These are some of the things that I just took an excerpt from Microsoft's website. So in the financial services, these are the areas that they explain in the white paper. Say that they can use blockchain to better these services like trade finance, commercial insurances, compliance, claim processing, and contract processing, and so on. Similarly, for supply chain, I'm mentioning these because when I go to any major blockchain events, these are some of the key application domains that people are talking about: supply chain, finance, decentralized IDs, and so on. So in these areas also, we can make transactions better. Decentralized ID is one of the hot areas that the industry is working on. I know that there are several companies and also several projects and industry members are working on decentralized ID. in SKT, I have a team that is actively working on blockchain use cases. So we have various use cases for exchanging this mileage points. Basically, I mean, you get credit points for your shopping activities or your other types of activities, and also participation in the music creation and also funding type of scenarios. Or, I mean, you can track how your driving behavior can be used to give you discount in your auto insurance. And in this case, I mean, you want the data that are provided to the insurance company is credible, and so on and so forth. So there are scenarios that we have worked on, and in order to support those kind of scenarios, we built these components and then created a demo, and some of them are going to be commercialized in the near future. Sorry, I think this is a video. I don't think I have time to show video here. And we have even in Barcelona this year at Mobile World Congress, we have shown how blockchain ID created by our company and Deutsche Telekom could work together and create exchange between the two. So we have capabilities to demonstrate all these cool things. So now, then is everything going okay? So that is a question, right? So one thing is that it's quite evident that, I mean, a lot of the excitement around cryptocurrency and blockchain has cooled down over the last year. Now, somehow Bitcoin is picking up, but we'll see. Another thing is that even for the popular dApps, there are not many users. So in the enterprise space, it looks like there are a lot of B2B businesses going on. But in the original idea that blockchain was going to enable that everything will be decentralized, no big power is going to have all the tools and the machineries. We haven't seen that yet. And there are a lot of questions, I mean, especially from the academia, to analyze, is blockchain really safe? Does it provide all the characteristics that it is supposed to provide? Now, I mean, initially Bitcoin was supposed to be, the POW should be done by all the decentralized servers, but as we all know, that a lot of the, I mean, server farms in China is doing the mining. And also there is a lot of, I mean, these, cases where you can observe cascade failures. So, I mean, I think some of the answer to questions are similar to the previous speakers. There are, I mean, a lot of fundamental questions. I think maybe academic questions. Is public blockchain really tenable? Is it possible to have stable coins that is theoretically provable? And I mean, trade-off between decentralization and incentivization, and also lots of, I mean, interesting questions regarding smart contract. If everything is going to be run and controlled by smart contract, then there are lots of issues. From the enterprise and business point of view, I think so. There are those, I mean, theoretical questions that we can really try to understand and push the boundary of the science. But I mean, even when we have all these use cases that these big companies claim to have, we still feel that there is no good platform to work with yet. I mean, it's still a hassle for software developers to develop dApps and apply them. And the management operation that is still, I mean, it has not been considered in any serious way in blockchain space. But if you think about all the modern IT system, these are essential components to make them really have, I mean, practical use. And also, I mean, blockchain, whenever, I mean, new technologies and algorithms are applied, then you have to sort of push the reset button. So how can we do continuous integration, continuous delivery type of stuff? And again, smart contract is a, practical issue. It's not a, just a theoretical issue. And I'll be happy to have, discussions on these topics. Okay, thank you.
Okay, over to Burkhard.
All right. Thanks for the invite, Salil. It's always nice to be last because it sort of avoid minefields. On the other hand, we delivered the slides before and no chances to move around. So that's a good thing to do. Let me start briefly with a few views on a sort of general scale on blockchains. I think life in society is based on trust, in partial cases on mistrust. And we do know about that type of assumption. So blockchains may try to implement that one-to-one. Based on the cryptocurrencies model, I think that is very close to real life. But on the other hand, we know that IT systems in this sense are no exception in general, because we do see many with trusted operators, maintenance people, sysadmins behind. So there's centralization. And that's exactly the difference, I guess, to many of these sort of clear distributed viewpoints of the blockchain case. I would not agree on the fact that blockchains and distributed ledgers are identical, because DLTs do make very different assumptions on trust compared to the blockchain, in case of the Bitcoin one as a sort of original one popping up. So the strong security in general is the basic foundation, because it offers us a chance of storing records inside a data structure, which is a backward linked list, an abstract data type. All we know as a sort of computer scientist. IOTA does it slightly different in terms of DAGs, but in principle, they are very strongly secured, that we are not able to easily change those ones if the right security measures are taken. And in proof of work, we all know that is a sort of collection of hashes, which are very hard to be done. So that's a sort of syntactical viewpoint of blockchains. And in addition to that, if we use that approach, there's no single player at hand who owns the data. All of them are within that decentralized storage. On the other hand, we have those quote-unquote facts being available and verified by many witnesses, and cheating becomes maybe very, at least hard. So these are the applications of our blockchain world within the application domain, because that is only valid, to my point of view, for data which are initially generated digitally. If you generate data not on an algorithmic fashion, we can easily provoke the old statement, crab in, crab out, because then there is no truth attached to that. And this is one of those misconceptions you see in many, many public statements of people talking about blockchains, that whatever is in blockchain is true. It's not true. If I persist the data in such a blockchain that I'm now in Zurich, I can't do so. Nobody will check that. But I've said it here, and so it's not true as such. On the other hand, we have whatever 2,100,000 blockchains these days, and already 800 plus died in the past couple of years. They are different in terms of public, private, quote-unquote, permissionless, permission, quote-unquote. And each of those shows very different characteristics, and especially on trust. And that's why I believe only public ones are real blockchains. All the other ones are DLTs, because in private blockchains, we suddenly have a predefined trust on end stakeholders, which we have to identify beforehand. And that's very different compared to the public idea of the first blockchain using cryptocurrencies as an application domain in terms of the bitcoins. Trying to go to the answers I was looking into, those ones I mentioned benefit best if the data are natively digitally, and we need to store them. If there's no need to store, why should you bother about a blockchain? Not really useful. At the same time, if you do have multiple unknown and interacting stakeholders, a blockchain makes sense. If any of those three elements is not the case, don't do a blockchain. Why should you? There's no need to make that happen. And this sort of trust model I mentioned before, and seems to be very, very important if the blockchain shall be really publicly available and accessible. and at the moment, to a certain extent, only applications which sort of have a low performance as of today with respect to data sizes, block sizes, interactions, transactions, frequencies, etc. might make sense. Moving forward, what are the challenges? I'm now clearly stating a little bit beyond what we have heard beforehand. There are none, because the Bitcoin blockchain, in principle, identifies all public related specific elements we need to know and understand. I'm pushing that very clearly to the top of the thing, because any of those elements right here are part of the blockchain called Bitcoin, as an example. But, of course, there's a whole bunch of different phenomena at hand, which are including all those multi-dimensional problems areas of storage, latency, real-time, or high-frequency transaction support in public blockchains, as well as the sort of generalized smart contract support, which partially is supported by Ethereum, obviously, but all the related costs with respect to proof of work and the fact that it needs energy. And as soon as we move away, I think that was very clearly becoming obvious this afternoon and this morning as well, if we move to proof of stake, proof of authority, proof of whatever, the security level of the data being persisted is reduced, I would say, dramatically, because they seem to be much easier to be quote-unquote faked, not in terms of fake news, but in terms of faking a simple consensus which has not been received beforehand. In addition, what are those enterprise things? Well, enterprise grade has a certain meaning, and I'm again pushing it to the corner edge. That is just a marketing term, which typically refers to the fact that it is business capable. And that means it's scalable with respect to which metrics, number of users, number of blocks, number of block sizes, transactions, energy, frequency, whatever you might name it. So it's nothing really different compared to anything of the traditional blockchain, at least from a scientific perspective. Maybe from an operational perspective, but from a scientific perspective, very, very identical. And of course, again, on the public side, the performance is still a bottleneck. And where are we going? Well, we're going an interesting path, waves, ups and downs and ups and downs. We finally end up at downs, because in 10 years we have whatever 5,000 plus blockchain, although with 4,900 did die. Very simply, because you take a look in the 1920s when car manufacturing popped up like crazy. Take a look at the car manufacturers out there at that time. Dozens of hundreds. How many can you name today? 10, 15, maybe 20. A few side things remain. So we are most likely in the same situation as in old quote-unquote industries with respect to blockchain and distributed ledgers. That's sort of the crystal ball I took out, but I forgot to bring it today. I cannot provide you any further details on that one. So those waves of decentralization and centralization will never stop, and blockchain-related things will appear and they will die, and it's a matter of taste. Because all those things which don't have multiple untrusted stakeholders can be implemented much easier, way more scalable in databases. And they're out there today. They're out there, they do their job. Why do we need to change? Only in case of real trust issues. And that means public blockchains. All the private ones are nice, but do they solve a real problem which we couldn't solve beforehand? I'm really questioning that. We might see things nicer, easier to be done. Maybe users might love it and like it. But technology-wise, quote-unquote, there's no change. The private role of the private blockchain role in the future seems to be unknown from my side, because we have those different trust assumptions in place I mentioned, and we have for certain distributed applications those values specified. So that's what I like very much in terms of value. There is value which you can persist. Tokenization means that you have a digital representation of value which is immutable. At least to a certain extent, we don't have those 51% attacks at hand, obviously. On the other hand, the public blockchains in that sense might be more advantageous, because those electronically derived data, especially cryptocurrency models, are exactly provable. Because if I show you a bit sequence which has been generated to be my Bitcoin, everybody can prove that. If I show you 256 bit of my SH256 and says, this is my apartment or whatever next to the state capitol, you look at me and smile. Can you prove that? No, I can't, but I can give you a number. So this is, to my mind, a very crucial difference, and the apps with similar type of data is clearly the case. But Having said all those negative perceptions on my side, we have to remind ourselves that the idea of decentralization will have, and already does have, and we see that in multiple areas in the world, a very strong societal and social impact, which is not to be underestimated, because there are some places in the world where suddenly you are able to register your land, your property, in a fashion that doesn't depend on a local authority which is not trusted, on a pure, let's say, societal, governmental situation. We may see sustainable goods being produced in some places of the world, cotton, cacao, coffee, whatever, which you can follow with a volume-based blockchain distributed ledger support, that will see a chance of identifying, at least after you've seen there were 10,000 tons of this being produced, but somebody sold 100,000 tons afterwards. There must be a problem. So that definitely helps. And when we talk to many people who see those application domains and work on those ones, they do see exactly that's decentralized as important. But for many IT-specific applications, distributing consensus is not useful because we have a much more efficient and much more helpful way to take that decision in a centralized, maybe in a pooled or sort of cluster way. Thanks.
Okay, so thanks to all the panelists. We are perfectly on time. So we've got about 45 minutes for the audience to ask questions, raise some discussion. So could I please invite all the panelists back up here and we can have you sit. Okay, so who wants to start? Are there mics here?
So one of the elements of blockchain that I don't know that any of you brought up is that they, at least a traditional chain, as it were, completely orders all sets of transactions. And while you might need that to be the case for an individual smart contract or bank account or what have you, most of the time, most pairs of transactions don't need to be ordered. And this is something that things like IOTA are trying to take advantage of. So whereas sharding tries to, increase the number of ordering units, how totally ordered versus how disordered do you see blockchain technologies of the future becoming?
So I think this was exactly the point I was trying to make with that slide with lots of little blocks, building blocks of blockchain, which is that if you have an application where ordering and timestamping is not important, then you shouldn't be forced into using a particular protocol that has that baked into it. You should have the freedom to kind of construct the solution that matches your application.
Yeah, I totally agree. Actually, yeah. So this comes with a penalty in a way, So if there is no need for it, then we shouldn't be using it. Having said that, there are applications. We do realize even at IOTA that there are applications that will be benefited by having total orders, and that's what we are looking into right now.
Yeah, I think in order to scale, we need smart mechanisms to make sure that these parallel executions can be allowed, right? I mean that's what has been actually done in the single computer as well, right? So I mean, if you think about decentralized technology like this, I don't think going forward it can be something that has total ordering in the entire system. That's not practical. So anything beyond that is more than test lab. So it has to be done in that way, in my opinion. I don't see any disagreement there. Yeah.
In a subset of fintech applications, total ordering is very, very important because you have the authoritative requirements of auditability of certain transaction happening on certain point of time and order. And then there's a whole bunch of, I would now say, maybe in contrast to you, that IoT applications in many cases don't really require total ordering because you just need at the end of a day, at a sort of end of period, end of an epoch, information that things happened. It might not fully depend on the specific order, and that is definitely a trade-off you can take. I'm not sure if that trade-off is worthwhile investigating in all the cases, because you might not have for those applications any specific ordering demands at all.
Okay, thanks. Yeah, any next up here? Okay.
My question goes into the aspect of applying blockchain with AI, in the sense that blockchain, we know about the GDPR, you cannot store data, it's encrypted, it's hidden, and so applying AI into that, how do we envision that happening, in the sense that the applicability of AI in that data, so that we don't have dumb data that we're sharing, but we want to apply AI on that, and also to the aspect of trust, because trust is really subjective, so how do we then handle that aspect of ensuring that it's trustable to me or to her or to anyone, because I see that as another challenge as well.
Yeah, so it's an area of interest to me personally. So I do think that with the multi-agent systems and in AI systems, we have examples of agents interacting with each other, establishing trust and learning who to trust and when not to trust. So these are the properties that have been studied quite a lot in multi-agent system setting. Now the question is that can we take some of it and apply it into blockchain? That's certainly possible for a number of reasons, but you have individual entities interacting with each other. There's a need for trust, but there is also a need to learn from your environment and be adaptive to that environment. And by that I mean that imagine if you are a node and you are receiving transactions from other nodes around you, and the question that you have got is whether or not to trust those nodes. It could be that you want to have a locally established trust, or maybe you want to give some nodes preferred treatment or more trust, basically. So then the question becomes, can machine learning or AI can help you? And I think that this is where there is definitely potential, because this is where agents can learn and agents can adopt.
I would make a very clear distinction between trust based on the outcome of an algorithm, which everybody knows, which is computed. And again, take this very silly example of cryptocurrency, or the Bitcoin case. We all know that algorithm, how it works, how it's generated, how the input is then consolidated / persisted in the blockchain. And this type of trust is based on the fact that we understand the algorithm. If you have agents doing things, we have basically a situation as we have in that room. We can talk between people and sort of build up trust over time, or misuse trust at a certain point in time when you're very highly reputed and you just turn the world upside down. You cannot prevent that from happening in the blockchain. You can prove it afterwards, but then it's too late anyhow. And that's way different, I guess, to the trust situation in a pure blockchain case. Blockchains do not help to make things trustworthier than beforehand. They just help to persist information on which you can point later on to, you have said that, I have said that, somebody else have said that, and you can sort of verify that things did go wrong. But the trust level is not assured by a blockchain, to my mind, at all.
I'd be a little careful to say that this is necessarily a problem that needs to be solved by blockchain, but there's certainly a decentralized trust component to it. For example, you can take federated learning algorithms, which allow different parties to hold on to their data while training a model. But the trust issue is, when I had this model trained by some entity, did they actually train it with valid data, or did they kind of manipulate the weights in such a way that it's making everybody else's decisions worse in some sense, right? So the point is to think clearly about the problem that you have, think clearly about the challenges with respect to trust, and then design a solution to that. Right? That may or may not involve a blockchain protocol necessarily, but it might involve many of the components that we associate with blockchains today. So I think that's part of the evolution of maybe the shift in our way of thinking about problems that will happen, I think, over the next decade.
Maybe I can be a little bit controversial here. Yeah? So to me, blockchain is created for trust. That's my viewpoint. The reason why I say that is that, I mean, if you look at, I mean, the history of, I mean, where, I mean, blockchain started from, and I mean, basically, I mean, people who started, I mean, thinking about this cyberpunk movement is basically they wanted to create, especially a currency system, without relying on government. I mean, that's printing money, right? So, like Professor Steele said, that Bitcoin has proved that it can work, right? I mean, you can exchange goods, whether it's an illegal good, whether it's I mean legitimate goods, but basically people can buy and sell with nothing other than digits that has been created, and there is no dollar or yen associated with it, and so. I mean, what does that mean? So right now we trust our money with the banks, right? Right now we trust our, I mean, sort of information with the Google, say. I mean, Google search tells you that XYG is XYG, then you sort of believe it. I mean, you trust it. Now, I mean, I think to me, what's interesting that blockchain as a community has raised a question is that, I mean, is that good enough, right? I mean, do we really... are we satisfied with that status quo, or do we want to come up with a technical solution, not a, I mean, trust as in I trust you type of solution, a technical, mathematically provable solution that I don't have to put my, I mean, this psychological trust to some entity. If I can prove the math, then I can be sure that there is I don't have to trust anyone, that the system itself gives that kind of insurance. So if we move away from that, then we can solve a lot of problems with enterprise blockchain type of stuff. But I think that is essentially, I mean, dodging the question. I mean, the straight question is that whether we can provide technological trust. And I mean, if we say, well, that's not the problem, then we are not tackling the hard question.
Yeah. Yes and no. If I take this algorithm of the Bitcoin part, then I can trust the algorithm if I have understood it, because the mathematics behind there determine very clearly how in a decentralized distributed system that consensus is being found. I can say, yes, that's something I believe in, or I don't. And the outcome is, at the end of the day, just quote-unquote a bit sequence with a few metadata, when it happened, which account were involved, plus the Bitcoin being transferred. If you do take all the other information, like IoT-based data being collected, we may only have trustworthy information if we take the time, maybe the GPS location, what else? CO2 emission? At that moment, temperature? Yes, but that's based on sensors, and that sensors can be completely miscalibrated. So there is very few elements just on the basic metadata which we collect. All the data on top of that are interpreted, because I read CO2 as being good or bad. That's depending on my observation. So that's why I'm sort of very careful what trust means. Typically, trust between people means that we believe that the other side argues in a sort of semantical way according to my understanding of the world.
So I completely agree with you. I don't think we can replace, I mean, human society level trust with some algorithms or some computer machines or something even fancier than that. What I mean is, basically, I mean, in the current world, right? I mean, that we live in, what do we trust? I mean, when we buy a house, I mean, we get this, I mean, bulk bunch of papers that is, I mean, basically deeds, and it has all this information about the house, and we pay money for that, right? And we feel the ownership of the house. Now, that system has been, I don't know how many 100 years, I mean, old, but I mean, basically that has been the case. Now, like you said, I mean, let's say, I mean, even though we say, okay, we only have limited, we can maybe capture limited information about some transaction happening or some sensor reading happening and so on. But it may be able to provide enough evidence that something happened, and that something happened can be actually, it can, for example, incriminate you in the court because you had illegal, you had a phone call, frequent phone call with some gangster organization, and that is suspicious enough that you can be charged. Versus, I mean, if you have an evidence that you didn't actually make those transactions and phone calls, then you might be free. So, I mean, even if we think about our, I mean, judiciary system and financial system, all the other administrative systems, we are based on old technology in a lot of the cases, and those things can be more objectively captured, and it can be provided as evidence. And of course, in some cases, I mean, because of this finality issues and all these, I mean, issues, maybe this can be, I mean, with probabilistic trust, it may not be either 0 or 1, but that may be much better than the current system.
Yeah, I totally agree. So that's exactly what I was thinking when you were saying that if you have the maths behind it, right? So you can trust it, but then that trust becomes a binary trust, whether or not you trust it or not. And I think there is also a case for probabilistic trust because, of course, if you have a system where there are no identity, everybody is anonymous, and it's very difficult then to trust anybody at all. But in cases where there is some notion of identity or some notion of locality, I guess you could. You could have a parameter that denotes the level or the degree of trust that you are willing to do.
Okay. Yeah, maybe we get the audience involved.
Yes, thank you very much. So I have a question is, in the view of academic, so I see that the most challenges for researching about the blockchain is that we can propose a protocol, we can develop an application, but we cannot get people involved into my application. So it's very hard to verify the feasibility of the system. Because in the lab, maybe we can develop the system with several nodes. But in the real society, so when the system applies for 100,000, a lot of nodes, so many problems will occur. So we can, in lab, we cannot test the performance of the system, whether the system good or not. So do you have any ideas how to overcome these challenges? And then, do you have any suggestion for the direction of the research in academic about the blockchains?
I think the short answer to that is academics should work with industry. If they're building real systems that are in the hands of thousands of users, that's where the data is that you can use for your research and do the analysis and so on. And of course, it's not to say it's a straightforward thing to do to get your ideas into somebody's production system. It may not be good ideas that they want to experiment with at scale with real users. So it's not that it's a silver bullet, but certainly I think taking that first step to work with people that are deploying real scale systems, it will have to be the source of data if you want that aspect of the research experience.
Yes, but in many, I see many cases, it's very difficult to get not all researcher can get contact with the industry.
Yeah, so it's an interesting thing. Trust actually among academia and there is a lack of trust, I think. I think there are a couple of things. One thing is that I totally agree that academia and industry need to work. We also have slightly different agenda. Academic research could be pure, basic, and a very blue sky, may result in 10 years, and this is fine with them. With industry, this is not the case. You have to come up with solutions which are needed, and you needed it yesterday. So there's always this pressure there as well. And I also think that with industry, I think there is particularly in this industry, say in DLTs or cryptocurrencies, the barrier to the entry barrier is quite low. So if you want to spin out a Bitcoin, yes, by all means, go ahead and do it. And it depends on how many people adopted your technology. But it's not that you have to buy some hardware or invest in an office and things like that. So the barrier is quite low, which creates also challenges in terms of trusting others. So if we have come up with a novel solutions that we are still testing or whatever, we would like to keep it to ourselves, because we know that if you put it out there, then there is a likelihood that somebody would just take it and run away with it without understanding what are the implications of using that solution. So there is that aspect as well. Second question that you asked about the academic research, I think where it's heading. So I think with industry, everything that is applied is relevant, and with academia, that's not the case. So it could be a security protocol that's they are working on, for example. But again, it could be blue sky research, and that's fine for academia.
Yeah, I totally agree with his comment. Basically, I think there are, good, synergy that can be made between academia and industry. But like Moody said, it's basically, in industry, the timeline is very short, and we have to show results every year, every quarter. So there are all those dynamics and the speed issue, basically. But we also, for example, SK Telecom works with academia in problems like, can we provide certain provable characteristic about the smart contract, for example, because those things are very important, but we don't have time to sit down and just look at the smart contract semantics and things like that. So those are more suited for academic problems, and then when we have the result, it can be used in the real world. So there is always a good synergy between academic and industry in this space.
Let me take the testing and experimentation issue you mentioned as well as an example. It seems to be sort of scientific academic dilemma in which we are in, because we all know if you have a very simple topology in old distributed system times, you have a bone and there's a whole bunch of nodes and there are a whole bunch of nodes on the other side. You can easily describe that, you can easily simulate that, you can pop a result out of that, you're done. But that has nothing to do with reality, because a network in between looks slightly different, just an epsilon more complicated. And as soon as you take that epsilon in real life into the picture, simulation is being very hard. So you need to move into real experimentation, and that takes time and lots of efforts, and you may end up in a whole bunch of different problems because nodes fail, protocols fails, energy supply fails, and this and that. Real life, real life, real life. And the outcome is not nice, because you cannot generate a bunch of curves, you only have a single curve. And then we send that in to a set of whatever journals, conferences, workshops, and they say, forget about it. This is just one case which is useless. You need to sort of the basic understanding, but we sort of evaluate ourselves in that way in two different mindsets. We want things which are very realistic, which might help industry, because we take SK Telecom's network as an example, if you would get it, with all the details, then we would have only a single result, which is really perfect, but then we are sort of harming ourselves. And this is sort of dilemma in which we're in. And all the distributed systems guys who did develop things like that in the past 20, 30, 40 years always see that. And the systems guys are always sort of smiled at, while the guys who generate millions of graphs are the winners, which is fine, because they are scientific evidence that things work well, but they are not always, I'm not saying realistic.
Thanks.
Thank you very much.
Yep.
So, how would you comment on the applicability of blockchain for data protection, especially GDPR?
If I may start. If you take the public blockchain, it tells it's immutable. And GDPR tells us, at least from the European perspective, that whenever you had a business relationship with a customer and a company, you can request from the company to delete your records. Done. Well, not completely done, because you might have had a good architecture where you didn't store the data on the blockchain, you had only the hash of the data on the blockchain. That sort of seems to prevent the solution, it seems to prevent from being a problem, but then we move in a jurisdictional situation, and we talked with our legal colleagues a couple times on that, because there are courts in the world who rule that a hash, like an IP address, is a personal data. So you got stuck in the same situation. Well, other courts rule a hash is impossible, of course, to be used to generate the original PDF stored to it, so you're fine. It's not a technical question anymore. It's a societal, jurisdictional situation in which we're in, and there finding harmonization is sort of hard. On the other hand, all those off-chain models, off-chain storage things will work. I mean, GDPR compliance, when the ruling is happening, you can probably go that way. So I have that sort of difficult thing.
But when we are saying storing the data off-chain, then we are basically not making the data, protected in the real sense. It would be mutable.
Not necessarily, because if you have the hash on the chain, you can always verify that the hash of the original document has not been manipulated with. There is some likelihood, we all know that there's a collision of hashes happening, but for that given situation, it's very, very unlikely. And this is one of the issues we raised before and as well. If that is an evidence in a court case, you have to persuade the judge that this evidence is, and I'm now be very critical, yes or no. Likelihood of 90% or 95% this is right or wrong, the judge will look at you and smiles. Because if it's a murder case, there is no likelihood. There must be proven evidence. And this is a very delicate thing. Today we've talked about a couple things where there are likelihoods, percentages involved. As soon as that becomes evidence in the court, it's very hard to persuade people that is real evidence.
I think there is a subtle technical issue there, which is that with hashes you can verify that it matches, but if the original data actually got removed or deleted, you can't get it back, whereas at least on a blockchain you had the replication capability. So this off-chain storage also has to be replicated and has to give you availability guarantees, right? So that's sort of the other subtle piece of using an off-chain solution to be GDPR compliant. You also have to guarantee that somebody can delete that data and you lose the other performance metric you might need.
IPFS as a potential way going that direction still has deficits though, but.
So I just want to add for those who don't know, GDPR is that's a data practice regulatory in mandatory in Europe only, I guess. Or is it? Yeah. With regards to your question, so I think it's an interesting discussion, as in whether or not the computed hash is actually is private. It should be considered personal data in a way that the IP address would be considered. My personal opinion is that it shouldn't be, but that's, it could be a biased opinion. But I think all of the security, all of the assumption is relying on the fact that given a hash, you cannot produce a data. And if that assumption is invalidated, then we are in a much bigger trouble than not being GDPR compliant, I think. So there is that aspect. And I also think that with GDPR, you will see that, with the EU has been, going on, I think, for at least for the past couple of years, taking inputs from businesses as in how exactly this thing will work in practice. They've got some ideas, but there will be revisions. And I think at that point, it might be realized that not everything, they can't treat all technologies in the same way. So they might have to make an exception if need be.
Just one more question. There are a lot of standardization works going on in blockchain. Do you have any available dates as to when some standards would be out for people to see?
This just a smiling answer. If you find a standard today which you don't like, wait for another one. It comes up tomorrow.
So just a comment on the question, is a hash private data or not? Consider the following scenario. There's been a video taken of you with your partner late in the evening doing things, and that video has been hashed onto the blockchain. And then some years down the track, your partner says, oh, you've divorced, and your partner says, oh, by the way, right, I can prove... ... Right? I think most of us would be concerned in that situation.
Yeah, I think there's that thing, despite the fact that you can't reproduce the data that is generated the hash, you still can use that hash to prove something, as you implied here. So what I can prove is the fact that this particular event happened at a particular date, and I can prove that it happened. But the original data will be deleted, whoever is storing the data. So you still don't have the evidence, but you do have an evidence that that event happened, or you made a hash at that point, in particular in time. So should be fine, I guess.
Hey. So my question is that one of the promise of this decentralization and blockchain is that now we can dismantle many of the centralized business model. And so maybe my question to the SK Telecom is that as a centralized big company is supporting this new advanced technology might have a damage in the major business model of the centralized company. Is there any kind of conflict of interest in there, or maybe in other panel, maybe this kind of new promise and shifting of major business model and the company structure itself is changing to a different model might be the kind of prevention or backtrap or kind of prevention force to hinder or delay the development of a blockchain and all these kind of technologies.
So that's a very interesting question, and I think that question is not just for SK Telecom, but all the establishment in the world, right? I mean, it's not just the companies, but also like U.S. Treasury Department. I mean, they are also looking at blockchain technology as, I mean, how do you use that basically? So we never know. I mean, which company will benefit from this new wave of technology, and which company will find new opportunities using this new technology. But I think what history has shown is that there are some, I mean, ways to do new things, right? I mean, used to be horses, now cars, and now electric cars, now self-driving cars. So let's say, I mean, electric cars. I mean, Tesla started the whole thing, but now if you look at all the major car manufacturers, I mean, they are, I mean, 99%. These gasoline engine powertrain guys, I mean, that's their, I mean, life and blood. But I mean, they have to change because otherwise they don't see future, right? So now blockchain, it's not a threat in itself in any major way to these major companies. I've shown the examples of IBM, I mean, Amazon and Microsoft, and those guys, I don't think they are seeing any real pain because of blockchain. Instead, they are trying to create new customer engagement opportunities using blockchain technologies. Now, if we say, let's say, I mean, blockchain guys, I mean, try to create next Google using blockchain, right? Next Facebook using blockchain, that they don't have to own our data. I mean, we own our data ourselves. So what do Google and Facebook do? I mean, they are doing blockchain research, right? I mean, in their organization, and try to find what makes sense to tokenize their part of applications. I don't see any concrete announcement from these companies, but they are, I mean, they have money and the company itself has order to hire any good talents and smart people to do interesting work, right? So it's to be seen. Now, what's clear to me is that, I mean, even though enterprise, I mean, even though you have successful business, it doesn't guarantee you anything in the future. So it makes sense for us to look at this new technology and opportunity and turn it into an opportunity rather than something that can eat your lunch. So I think that's our basic, starting point. And what we are trying to do is actually start applying these technologies where it makes sense, and only, choosing the technology that are usable. Because some of the things that are like public blockchain, I don't think any company can use public blockchain public permissionless blockchain to do their business. So, and some people will say, oh, that's not really blockchain. I mean, these guys are just saying that they are doing blockchain, but it's not. But so there are lots of, controversy that can be done. But I think what's important is that it has to be done. I think it's very important that academics look at this problem and find path, what is possible, what is not possible. And the enterprise also experiment with real world problem, and some of them will succeed. I think some of them will fail, but I think that's how it goes.
I think definitely the bigger companies will deploy their capital in ways that are advantageous for their companies. That's what they're supposed to do. And will that shape the way the technology evolves? Absolutely. Does that necessarily mean that particular ways of developing this technology will be naturally better because they were better funded? That's not necessarily true, right? I think if the one thing we've learned from technology is that it can often be very disruptive to established companies that are highly capitalized because they miss out something, some new capability that arises, right? And so I think it's not, let's say, guaranteed that just because large companies have a particular way of looking at technology that investment or that particular approach will be the one that pans out. That's the best I could say.
Yeah, I think it also depends on not just the technology they are developing, but also the future scenarios. Like we will have, people say, 50 billion devices, but then how exactly are they communicating with each other? And your technology will come down to the fact that how these things are, as you implied, the networks in real life. So there's that aspect. There's also an aspect of with centralized solutions, with permissions, blockchains, there are definitely use cases for them. So it's not the case that any technology that develop will not be useful in that context. It will be useful, and the question is that how much of that technology that they come up with, whether or not that's not considering patterns, if that can be used in some other domain, say permissionless networks. So I also want to add that the one thing is that I find difficult to believe is that sometimes it is thought that we will have a truly global system where we, anybody who does anything will be seen by everybody in the on the node, which I find it difficult, because if I am buying lunch here, for example, in Seoul, then the person who is in somewhere in London or San Francisco or anywhere, do they really need to know about that transaction? But if they don't, if they don't, then the concept of having this global super availability to everybody of every transaction possible, that collapses, and it collapses into economic clusters. So you will have probably a cluster here in Seoul, or people using some sort of currency, or it could be any other data. But the point is that so you were talking about centralization. So there is that aspect, that there will be companies with centralized solution, but then there is also this aspect of having economic clusters, which is not really a centralized solution in its nature, but it is still, it's a it's a localized solution in a way. So yeah, I just wanted to add that.
Yeah, maybe James and then here.
This question goes to the folks in industry, IOTA and Kang-Won at SK Telecom, perhaps. As you are doing research and development, and probably doing more development than research, but at this point, whatever the applications or chains that you're developing, what is lacking? What do you need more? If it's human resources, what sort of talent and expertise are you looking for from them?
I think what sort of challenges we are looking at in industry. So I think, so talking about IOTA, my personal experience, I think we have, there is definitely a need for more human capital. The talent is there in this field. This field is relatively new, so there are people who have, if you go 3 or 4 years back, there won't be anybody who's done a PhD on blockchain, say. So there are people who are coming from different backgrounds and taking on the challenge. So there is definitely a need for human capital. And I also think that this is, as it was actually referred to earlier, that lots of the things that were done from a very engineering point of view. Very little was thought about how exactly do we do it in a scientific manner. When we run simulations, I've seen cases where people say they have run a simulation with particular parameters, and that just proves that that their technology is going to work, which isn't really the case, scientifically speaking. So I think there is a dire need of bringing a rigorous scientific discipline to everybody who's working on that. And I also think that the challenge itself is very difficult challenge. It is difficult because we want lots of things, and we probably want it now, right now. Actually, that's that analogy. But we want lots of things. We want anonymous solutions. We want identity. We want permissions, permission or permissionless, and we want scalability. So a solution that meets the demands of tomorrow is a challenging one. But I think I'll end it on an optimistic note, which is that I think that given that the attention it has received, given that the academia and industry is now really seriously looking at solving this problem, I think I'm optimistic that there will be not our solution, but solutions, practical solutions to this problem.
Yeah, in terms of skill sets, right? I mean, like Moody mentioned, that there's no one majored in blockchain per se, right? But I don't think that's necessarily a problem, because I mean, essentially what we are trying to solve is distributed computing problem. We need good systems people. We need good people with strong, crypto background. We need people with economics background to design token economy and so on. One challenge is that probably, there is a lot of demand on blockchain, and I think a previous person questioned about industry, and there are a lot of industry entities, big corporation, that are trying to hire who can develop their blockchain system, but they cannot find resources. And this is, I think, maybe characteristic in Korea. I don't know about other countries what the situation is, but because the previous years have overheated with the cryptocurrency and blockchain in Korea, so a lot of the people actually who were working in the traditional IT industry went to blockchain startups and the crypto startups. And then I don't know how it went, but it's sort of, you cannot find really people in this space to hire, right? So in my case, our team has actually my core team used to work on distributed system, distributed computing, and they were, transformed into blockchain. They learned the protocols, and basically they studied anew. It was not too difficult for them to catch up, but in a sense, I think it's a problem everywhere. If you want to hire someone in AI, it's very hard to find resources in Korea. Same case with blockchain. If you want to hire someone who can do blockchain, it's very hard to find. Especially big companies are difficult to attract talents. They want to start their own business. So I think that's what it is. But yeah.
Okay, I think just
Can I-
one
can I-
last.
Sorry, can I just do a shameless plug-in that we are looking for researchers. So if you are interested in our technology, then please do check out our website. It's everything is there. Yeah.
Okay, thanks. If there is one last quick question, yeah, please.
Coming from an internet background here, looking at the impact of internet impacting on society, is it the problem blockchain we're facing now? Is it because the actual technology is riding on the wave of the internet? That is the constraint.
So, I see it as an opportunity, but there are things that we got wrong in the design of the internet. I think, one example that was brought up in presentations today is a lot of application layer services on the internet are centralized, whether it's DNS or PKI and so on. And so, from a research perspective, that's an opportunity then to go back and rethink some of that. I brought up this question of how do you, pay for data, but at a protocol level. That's not something that exists on the internet today. But I think, at least as a research community, these are opportunities we have. I don't know to what extent people see the internet itself as a constraint. I think we wouldn't even be asking questions about exchanging value with remote strangers if it wasn't for the internet. So I personally, don't see it as a problem in itself. It's just that there are things we need to work on.
So that's a very interesting question. I think maybe there might be some constraint because of the way that internet was designed, and there was no way. The designers of the internet, could forecast this type of problem, right? So it's an interesting evolution, right? We actually have parallel network systems in our world, right? One is all this telco-based network, which developed from this old telephony system. Now they are sort of they are carrying TCP/IP over the cellular signal. But if you think about it, actually, this might be another, interesting turn because so blockchain. So if you, one thing is that, for example, I heard that in Japan, credit cards are not as widely used as Korea because they had very strong traditional transaction system. So for small stuff, they have to use cash. Now in Korea, interestingly, you can buy any small things like chewing gum. You can just pay for using credit card. Now if you go to China, they can do everything by mobile phone, right? They don't even carry a credit card. So if you look at all the establishment, actually, it's not their advantage. It can be their disadvantage. And the technology like blockchain was, when people maybe it started from US, but it might find more interesting use in underdeveloped country where less infrastructure, which has less, secure financial systems and things like that. And in those countries, everybody use their transaction using phones, right? So blockchain with the cellular phone might be the new way how it will be designed. So I don't know whether it's going to be solely based on internet like we do in the more developed country, or it might be more ad hoc or more. Maybe it can have a different turn. So it's something very interesting to be seen.
Okay, so I'm an advocate of DLT, blockchain, but I would like to play the devil advocate by asking 3 short questions. So the first question is, unless we do want to melt this planet down, proof of work doesn't work. At 7 or 20 transactions per second, it cannot scale. I mean, it's simple mathematics, like primary school mathematics. And proof of stake has fundamental problems because the money are calling the shots. So the first thing is, where do you think the future of blockchain is going to be going when it comes to validation, consensus, and so forth for permissionless networks? The second question, it's the adoption of the blockchain. In the last 5 years, we've seen like this going like a stock market. Like when you go to Bitcoin magazine, bulls, bears, like half of the advertisements about that, right? So for me, that worries me because it just takes another crash and people gonna be losing trust into this ecosystem. Just like people lost trust about stocks in 2008 and so forth. So where do you see the adoption, and do you think that the adoption is the cryptocurrencies, that the value is going up and down and so forth? And the third thing is the regulation, essentially, and the governance of this system, because Vitalik is very influential in Ethereum. Those folks behind the Bitcoin Foundation are very influential about the forks. So is it truly decentralized, and where do you see the governance moving? So the first question is the proof of work, proof of stake. Second is like this futility about the values of the cryptocurrency. The third is the governance.
Maybe if you can just very quickly address.
So I'll just come in with the proof of work. I think it's people are working on getting rid of it. Whether or not this can be perfectly replaceable, that's another discussion. But yeah, people do realize that it's killing our planet, and it is also costing resources and money, basically. The second question was with regards to these all these bear and bull runs. I think it's what's known as the tragedy of the commons. If there is a shared resource, could it be trust or anything, and people could make use of it freely, then they will make use of it freely. And this is the case, anybody can start a coin and market can go up and down. But this is also on a par with lots of other businesses in past. Banking wasn't as reliable as it is today. Bonds are, so you can look into these things and there will be different parallels. The final question was, sorry. The governance, yes, I see. My personal opinion is that there is, governments will regulate, and there may be some advantage of regulations in terms of facilitating these systems. But that's my personal opinion.
Okay, unfortunately, we've run out of time. So please join me in thanking the panelists for giving us their time and insight.